Okay, this video is about problem number 6 in our review packet. And in problem 6, we are taking word equations, A, B, and C, and translating them into balanced chemical equations, the molecular version. So the first thing you have to do in one of these equations is create the chemical formula from the name. So aluminum sulfate, we start by writing the symbols for aluminum and sulfate, Al and SO4 for sulfate. We look up their oxidation numbers, and aluminum from the periodic table is a +3, sulfate from the periodic, or not from the periodic table, but from the polyatomic list is a -2. So we swap and drop. That 2 comes down here. The 3 comes after the parentheses for sulfate, because remember, we don't want to write a 43 accidentally, so we group it with parentheses. Do the same thing for calcium hydroxide. Write the symbols, Ca, and hydroxide, we go to our polyatomic chart in our reference tables. We look it up and find that it's an OH, and it has a -1 charge, while calcium has a +2. So we will need 2 of these hydroxides to balance out the charge from calcium. Then we draw our arrow and do our products. Aluminum hydroxide. Well, again, we write our symbols, Al, and then OH for hydroxide. Okay. We're not going to carry this 2 over. Instead, we're going to swap and drop, or crisscross if you prefer, once again, using their oxidations. Aluminum +3 from the periodic table. Hydroxide is a -1 from the table of polyatomic ions. You swap and drop, and you're going to need 3 hydroxides to balance out that +3 on 1 atom of aluminum. And finally, our last product is calcium sulfate. Symbols, Ca, and then SO4. Calcium is a +2, sulfate is a -2, so we could swap and drop, and then we'd wind up having to simplify, or we can just recognize +2, -2. The charges are already balanced, they add to 0, and so the formula is CaSO4. We're almost finished, but the last thing we're asked to do in number 6, is to balance these equations. So this equation is not yet balanced. I can just look at sulfate and see that it's out of balance. There's 3 going into this reaction, just 1 coming out. So let's start with sulfate. I'm going to throw a coefficient of 3 in front of the only product that has sulfate in it, calcium sulfate. Now I have 3 times 1 sulfate, so 3 sulfates coming out, 1 times 3 sulfates going in. Balanced. Okay, sulfates are balanced. Let's move on. Let's check something else. 1 calcium, 3 calciums. Well, that's not going to work. So we stick a 3 in front of calcium hydroxide in the reactant side. Why? Because it's the only reactant with calcium in it. So 3 times 1 calciums is 3 calciums going in. 3 times 1 calciums, 3 calciums coming out. Alright, so let's pick something else to balance it. Aluminum, 2 go in, just 1 comes out. So we can remedy this with a coefficient of 2 in front of aluminum hydroxide. 2 go in, 2 come out. Now we can check our hydroxides. 2 times 3 is 6 hydroxides coming out. 3 times 2 is 6 hydroxides going in. This equation is now balanced. And if we want to, we can go ahead and throw a coefficient of 1 in front of that aluminum sulfate, but by no means is it required. Alright, so moving on to B and C, aluminum plus hydrochloric acid. Well, aluminum is just an element, symbol Al, plus hydrochloric acid. Little clue with our acid names, the prefix hydro tells us that it's a binary acid, and so we're going to have to look at the periodic table in the nonmetal section to figure out what the second element is. But before we do that, we can just recognize that an acid always contains hydrogen. So I'm going to start the formula by writing an H for hydrogen. Well, chlor, as in chloric acid, tells us that the element is chlorine. So this would be hydrogen chloride, but when it's dissolved in aqueous solution, it's called hydrochloric acid. So H crossed with Cl plus 1 from the periodic table, minus 1 from the periodic table. The charge is balanced, we don't need any subscripts. So aluminum plus hydrochloric acid reacts to produce aluminum chloride, symbols Al, Cl. We look up the oxidations. Aluminum is a plus 3. Chloride is a minus 1. It's going to take 3 chlorides to balance out 1 aluminum. Then we add hydrogen gas. You might think it's just an H because hydrogen is an element by itself, and so the symbol is just an H, but remember, hydrogen gas is one of those 7 diatomic elements, and so we write it as H with a subscript of 2, molecular hydrogen. Alright, now we balance. And we can balance this equation by putting a 2 in front of aluminum, 6 in front of hydrochloric acid, 2 in front of aluminum chlorides, and 3 in front of hydrogen gases. Alright, last equation, lead-2 nitrate reacts to produce lead-2 oxide plus nitrogen dioxide plus oxygen gas. This one's actually going to be a little bit tricky to balance, but first let's start by writing the formulas for everything. Lead-2 nitrate. So the symbol for lead is Pb. Nitrate, ATE, according to our polyatomic sheet, is NO3. That's the symbol. Now, oxidations. Nitrate, according to our reference tables, is a minus 1. Lead, we cannot tell from the periodic table because this is one of those exceptional metals here, even though it's in group 14. It has 2 possible charges, plus 2, plus 4. Fortunately, it's in the name, lead-2. That means this is lead with an oxidation of plus 2. So if lead is a plus 2, nitrate's a minus 1, I need 2 nitrates to balance out that 1 atom of lead. Now it decomposes to produce lead-2 oxide. Again, lead, Pb. Oxide is just oxygen, so O. We do our swap and drop, plus 2, minus 2. Cancels out, no need for any subscripts. So, moving on. Nitrogen dioxide. Well, this one is a covalent compound. You can tell because it has a prefix in the name. So, nitrogen, symbol N, oxygen, symbol O. The di is a prefix which means 2. And since there is no prefix on nitrogen, we know that it's actually mono. Anything other than 1 in that first place, and it would have to be listed. Without a prefix in that first place, we know it's mono. So N subscript of 1, we don't write it, O subscript of 2. Last product is oxygen gas. This is another one of those diatomic gases, so O subscript 2. Now, when we're going to balance this, there's a couple of ways to do this. I like to recognize the fact that the nitrate is breaking down to form the nitrogen dioxide and the oxygen gas. So we kind of have this NO3 falling apart into NO2 and then an atom of oxygen. But of course, what's also happening is one of those atoms of oxygen is going to make the lead-2 oxide. So if we count up the oxygens going in and the oxygens coming out, we're going to notice a bit of a problem. There are 6 oxygens going in, 1, 2, 3, 4, 5 oxygens coming out. Even and odd numbers are never going to balance out nicely. So what we're going to wind up having to do is to double something. And notice these have 2 even numbers here, 2, 4. This is our odd oxygen out. So let's go ahead and double this one particular product. So now we have 2 PbO. 2 times 1O is 2, plus 2, plus 2. That's 6 oxygens. Okay, so now that we have this, we're going to wind up having to double our Pb over here. Okay, 2 leads coming out, 2 leads need to go in. So 2 lead-2 nitrates producing 2 lead-2 oxides. 2 leads, 2 leads. All right, now that's safe. There are 2 times 2 nitrates going in. So we're going to have to break this down into There we go. 4 NO2s. All right. We have 2 times 2 nitrates. That's 2 nitrogens times 2 is 4. So I need 4 nitrogens coming out. All right. So now the nitrogens are balanced. Let's look at oxygen. 2 times 2 times 3. Well, 3 times 2 is 6, times 2 is 12. 12 are going in. We have 2 times 1 is 2, plus 4 times 2, which is 8. So now we have 10 oxygens over here, and 2 more oxygens makes 12. So coefficients of 2, 2, 4, and 1. Okay, so this is problem number 6 on our review packet. Tune in for the next video for problem number 7.